Hello, I'm Dr. David Kordowitz, and welcome to Programming. Today we're going to be introducing the idea of conditionals in MATLAB, as well as discuss how loops work in MATLAB, which is slightly different than how they work in the C++ environment. Let's begin. So today we're going to begin with a script file that begins with our standard close all clear vars CLC that allows us yet again to clear all the previous variables, close all of our plot windows, as well as clear the console, so it makes the command window new, so that if there are any errors, we know it's from this run of the program and not a previous run. So let's look again at our conditionals, which we had from C. So in C we had, so let me say conditionals. In C we started with our equivalency, which we said was equals equals. So let's say C, and then we're gonna do MATLAB. Okay, in C we had talked about our equivalency, and that was equals equals. In MATLAB it turns out that it is the same, it is equals equals. In C we had our not equal as exclamation point equal sign. Well, it turns out that in MATLAB the exclamation point means external reference to system. So the exclamation point actually calls programs on your operating system, so we can't use that to represent not. Instead, we use the tilde. So it's tilde equals is our not equal. So this also implies that our not is going to be our not, and it's going to be a tilde. Okay, we had talked about greater than, and that is in MATLAB also greater than. We talked about less than, which in MATLAB is also less than. And we had talked about greater than or equal to, which is the same thing in MATLAB, greater than or equal to. And then we had finally our less than or equal to, which is the same as our less than or equal to. So basically the only place that we have a difference is in the not command. There are some other finer differences. So for example, and or are slightly different. So you can use the single ampersand. So in C we had talked about that it was and. Here you can get away with just a single and or an. Or you can do and A comma B. All of these work correctly. And in MATLAB, the or command in C was double or. Here it's or A comma B. It's a lot of ors in a single sentence. Okay, so now let's look at this in practice. So we're going to write that coin flipping program that we had seen earlier in some of the example code. So the first thing we're going to do is get a random number. Random numbers from the standard random generator are what we call uniform random numbers, which means you're just as likely to get any number between 0 and 1 as any other number. So what we're going to say is value is equal to random, and we only want a single one. Now in MATLAB, you don't need to put the parentheses after a function if you're not feeding it any parameters. So in this case, rand is just fine. It knows what to do with that. So now what we can say is if rand, or if val, is greater than 0.5, then what do we want to do? Well, let's say that that is heads. So we're going to say okay, well, if val is greater than 0.5, then we're going to say side equals heads. Then we're going to say, or side equals heads, let's say heads is 1, because you can't say the word heads. Else side equals 0, so it's tails. And then we're going to end this with an end. We can then say over here, if, and we don't need the space, side, we can then say disp heads, else tails. Now if we run this, we're going to get, for example, heads. And we can keep flipping this coin over and over again, and each time we flip it, we're going to get a different value. So in this case, I got tails. So you can see that this allows us, these if statements, these conditionals allow us to do very much the same thing we did in C. Now, one catch is, let's say I want to say if it's exactly equal to 0.5, I want it to be, say, edge. Say it's the edge or something like that. So we can say else if, and notice it's all one word, and we can say val equals 0.5. Then we're going to say side 3. And then we can come down here and we can say if side equals 1, heads, if side, else if side equals 3, then we want it to display edge. Okay, so now in the very unlikely case where our value is exactly 0.5, we're going to get edge. So let's run it a few times and see if it ever happens, and it shouldn't, because it's so rare that you're going to hit exactly that value. But you can see that we get a good collection of heads and tails. We're going to run a for loop to run it 100 times and see if we get some interesting statistics. So what we're going to do is we're going to go on the top here and we're going to add a for n equals, say, 1 to 100. So that's going to run 100 iterations. Now what we want to do is we're going to say, okay, well, instead of just going to side, we're going to go to side of n, which is our iteration variable, and we're going to say side of n, and we're going to say side of n. So now we're going to store our states, but we need to go up here and create n so that when we iterate through, we actually have we need to create side because we need to make sure that we have somewhere to store things. Well, now let's go ahead and pre-allocate. Since we know that there's going to be 100 trials, or even better yet, we can say n equals 100 for our number of trials, and now we can go from 1 to capital N. We can also go and say side equals zeros, and we're going to make it zeros, and the size of it is going to be 1 by n. Now, all we need to do if we want to change our number of trials is simply change this n, and it will update for everything. Now, for simplicity's sake, I'm going to go ahead and hide our displays. So if we hide that, we can do Control R to comment all of it out, and we're going to store our values. Now, I want to go through, and we're running 100 times, so we're going to say end to end our loop. And now what we want to do is we want to go through our statistics. So we can do a really sneaky trick here, and all that is we're going to say, okay, add up all the times that it's equal to a given value. So we can say tails, for example, capital T equals the sum of side equals 0. And what that's going to do is, in the case of tails, we can say side equals 0. Every time that's equal to 0, we're going to get a true, which is a 1. And if we add those up, that tells us how many times true came or tails came up. And we can do the same for heads. And we can do the same for edge. Now we can make a nice little display for it using the disp command, and we can say disp. And this is how you're going to build an array up. We're going to use a square bracket, and we're going to say tails, and then single quote, and then we're going to do a num2 string, and we're going to change t. Then we're going to do comma and put another quote and a space, and we're going to say or comma space heads, and we're going to use num to string, and this is going to be heads, and then comma, quote, comma, space edges, and there it is. And close the square bracket and close the display and semicolon. Now, one thing to notice here is this line has gotten really long. So in MATLAB, we can use the ... or ellipsis command to continue on another line. So I can go ... and then take this down and then continue with our ... And there we have it. So now it's all on 3 lines, but it's all 1 line of code because the ... tells it to connect. Okay, so let's run this and see what happens. So we run this command and we get 63 tails and 37 heads. So what is that telling me? Well, that's telling me that there's a slight bias towards heads or towards tails. So let's come up here and say maybe this should be greater than or equal to, but we have our edge for that. So let's run this again and see what happens. Well, now it's about even. And each time we run it, we're going to get different results as far as how many of each we get. So in this case, we got perfectly 50 and 50. So this is telling me that the random number generator is fairly random. And so using our loop, we're able to do many trials really quick. What if we wanted to check now if we ever get edge? We could do that simply by saying we can do a while loop down here, and we could say while rand is not equal to tilde equal. When rand is not equal to 0.5, we want it to keep going. So we're going to just keep going, and then we're going to do an end, and we're going to say, okay, well, if it gets the end, then display edge. So now if we run this, it's going to run for it should run for a really, really long time before it hits its edge and displays the word edge. And it's still running right now from the previous runs. What it's doing is continuously randomly sampling until it gets the value that we're looking for. So this is another way to use loops. So this loop will run while rand is not equal to 0.5, so it just keeps drawing until it gets there. So this is the basic introduction to the conditionals in MATLAB and how they're slightly different, as well as how loops work in MATLAB. And again, they're slightly different too, but it should, if you understand them in C, be clear. I'd like to thank you for your time today, and see you next time.